All right, my friends, we've now finished up our first application. In this video, I want to do a quick review of the very important concepts we learned. So the first important thing that we covered was that we wanted to restrict the amount of API surface area exposed inside of index.ts. So in other words, if another engineer opened up our project and only had access to this file right here, we wanted to limit the number of things that they could do. They could only do things that you and I had specifically allowed inside of our application. So for example, another engineer could only create an instance of a user and read its name property and its location. Another engineer could only create a company and then reference its company name, catchphrase, and location. And with a custom map, another engineer could only create an instance of a custom map and then call that addMarker method. And as far as our code is concerned, that's the only thing that other engineers can do inside of here. The most important aspect of this was that we wanted to restrict access to that Google map that we created. Because remember, the Google map had a ton of different properties associated with it. So to make sure that other engineers could not mess with this thing, we added on that private modifier. The private modifier means that we can only reference this property from methods inside of the custom map. So for example, back inside of index.ts, if we tried to refer to custom map.googlemap, we got that error message that said, this is a private property and you cannot access it unless you are inside of the class custom map. Now, I know 100%, I know what you're thinking, but Steven, other engineers can just open up this file and start calling this or accessing this property directly from inside this class. Yes, I agree with you. Another engineer could open up this file. But the idea here was simply that if we viewed custom map as being like a black box or kind of like a mystery thing of sorts, we limited the damage that other engineers can do. So we just exposed the bare minimum amount of functionality to allow our application to work and nothing more. So another engineer absolutely can open up that file, but if you just kind of view this variable right here by itself, there's only two things we can do with it: create an instance and add a marker. That's it, nothing else. The next big thing we spoke about was our interface inside of custom map. So we ran into many issues around this addMarker function. We initially saw that we had two different addMarker functions, one for business, or one for companies and one for users. And when we had that duplicate definition, well, we had a lot of duplicate code. So as an initial approach, we tried to say that addMarker could take many different types. So we had addMarker, and we said that you could pass in a user or a company. And then if we had additional types inside of our application in the future, you could pass those in as well. And so the bad thing about this approach is that it set up a dependency between custom map and all the different things that we would want to map inside of our application. So as soon as we started to add in more things that could be represented on the map as a marker, well, we had to go back and update custom map, which would have been a very easy time for us to accidentally introduce bugs into our application. So to fix this problem, we inverted the dependency here. We said, instead of custom map trying to accommodate all these different classes, we instead say, hey, other classes, you have to accommodate custom map. So inside of custom map, at the very top, we put some instructions on how another class or instance of the class could be an argument to addMarker. We did that by defining an interface. So that was equivalent to custom map kind of standing up for itself. Custom map got up on a podium and it said to all the other classes inside our application, hey, other classes, if you want to be an argument to addMarker, here's what you have to do. You have to define a location property that has a latitude that's a number, longitude that's a number, marker content that returns a string, and color that is a string as well. Remember that we did not specifically have to update those classes and tell Typescript, hey, I want my user to be an instance of mappable. We added this on only way later inside the application. So we did not have to specifically say, hey, Typescript, we want user to be an argument to addMarker. Instead, as long as we had the correct properties, Typescript did the appropriate checking for us invisibly behind the scenes. As soon as we tried to pass in user or company to addMarker, Typescript automatically took a look at user and made sure it had the correct properties. As long as it did, awesome, thumbs up. You can be an argument to addMarker. So again, the whole idea here was that we wanted our custom map to tell other classes what they had to do to be an argument. Now the pattern you see right here is going to be a pattern that we repeat so many times, again and again and again and again. Remember, I've told you many times that, or at least once, I should say, that in TypeScript, the big thing we want to learn, and like the big killer feature of TypeScript, is the interplay between classes and interfaces. And that's exactly what you are seeing right here. This right here, this is the killer feature of TypeScript. And this is how we're going to write awesome code. So just about every project that you and I work on is going to have an identical structure. Every TypeScript file we work on is going to be something like this. At the very top, we're going to have a number of interface definitions. Maybe it's 1, 2, 3, 4, however many. And those definitions are going to describe what you have to do to work with a class. So our class definition will have a couple of methods, and if a given method has to receive some other object to work correctly, rather than specifying that other object type, we're going to instead specify an interface. So other objects inside our application can choose to implement that interface so they can work with this class definition. And that's how we're going to get this awesome amount of code reuse and very low coupling between different classes inside of our application. I can't say it enough. We're going to see this pattern again and again. This is the whole point of this course, is to help you understand this pattern. Well, a couple other things as well, but you understand. Okay, one last big thing here. Last thing I want to mention is that if we wanted to, we could help TypeScript give us help. So when we start working with this interface stuff, we want to make sure that we start to see errors in the correct location. So to help TypeScript show us errors in our interface definitions in the correct spot, we can optionally choose to implement an interface. So inside of user TS, we imported the mappable interface, and we told TypeScript very directly in this case, hey, TypeScript, we want our class user, or an instance of user, to be compatible with the mappable interface. So to do so, we optionally add on implements mappable right here. And that tells TypeScript we are trying to make a user satisfy the mappable interface. By adding that in, TypeScript is going to take a look at our user definition and make sure that we are implementing the correct properties. Again, 100% optional. The only reason we do this is so that we can kind of help other engineers understand what we're doing with this class right here. So if another engineer saw this statement, they would understand, oh, okay, I get it. We want a user to be mappable. The other reason we add this in is so that TypeScript can take a look at the different properties here and help us make sure that we add in all the correct properties. Okay, so that's it. That's the 3 big important things here. Once again, inside of index.ts, we wanted to restrict API surface area. Second off, we wanted to use interfaces to set up a type of dependency between the different classes inside of our application. And then finally, we can help TypeScript put errors in the correct location by using this implements clause on classes. So with all this in mind, let's take a pause right here. We're going to go in the next video and start working on our next application.